Okay, fun section. 8.1, Thomas's Intro to Sequences and Series. He starts out by letting you know that a sequence is a list of numbers that follows a specific pattern. 3, 6, 9, 12, 15. You would look at that and you might say, well, these are adding 3, or 1 times 3, 2 times 3, 3 times 3, 4 times 3, 5 times 3. You could predict the next one and on and on. This next series, 1, 1, 2, 3, 5, 8, 13, etc. You might recognize those numbers. You might have run across them somewhere in your life. That's a Fibonacci series. This is what happens here is you add the two previous terms. So to get this term, you add the two previous ones. To get this term, you add the two previous ones. To get 5, you add 2 plus 3. To get 8, you add 5 plus 3, etc. So if we wanted a new one, we'd have to add 13 and 8, get 21. In order to add another one, in order to get this next term, you'd add these two. So you get 34, and on and on and on. Fibonacci series there. In all cases, this first term is called A sub 1 because it's the first one in the series. This guy, 6 and 1, 6 in this one is called A sub 2. 9 is A sub 3. It's the third term in the series. 1, 2, 3, 4, 5, 6. So A sub 18 is the sixth term in the series. 1, 2, 3, 4, 5, 6, 7, 8, 9. This would be A sub 9. It's the ninth term in the series. Number 1 asks us to write the first 4 terms. A sub n is 2 times n plus 5. So if we want the first term in this series, we'll call it A sub 1. It's the first one we're doing. And that is 2 times 1 plus 5. That's 2. So 2 plus 5 equals 7. So A sub 1 is a 7. That would be the first term in this series. A sub 2, the formula is 2n plus 5. This is a closed formula. That means that we can go grab any number we want. We're going to find the second one. We'll multiply 2 times the n. The n is a 2. Just put n, the number that is n, in for the place of n. It's a plug-in. 4 plus 5 gives us 9. So the second term in the series is a 9. A sub 3 is 2 times 3 plus 5, gives you 6. So the next one is an 11, and you can see how this series is progressing. And they want the fourth one. So 2 times 4, you're always putting into the formula 2 times whatever the n is. That's 8 plus 5 equals 13, and you can see how that series progresses. If we wanted to find a to the 53 term, the 53rd term, we would just say 2 times 53 plus 5. Multiply those, you get 106 plus 5 is 111. They didn't want that, but you could do that easily. 1b is also a closed formula. All we got to do is plug in to find the number we're looking for, 2 to the n plus 1. So if we're looking for A sub 1, the first term in the series, we're going to plug in a 1 everywhere there's an n. So a 1 there, 2 to the first plus 1. Negative 1 to the first power is a negative 1. 2 to the first is 2. 2 plus 1 is 3. That's the first term in the series. A sub 2 is a negative 1 raised to the n power over 2 raised to the n power plus 1. So we're putting our second term in for the n's. Negative 1 times negative 1 is a positive 1. 2 squared is 4. 4 plus 1 is 5. Negative 1 to the third power over 2 cubed plus 1 will give us the third term. Negative 1 to the third power is a negative 1. 2 to the third, that's 2 times 2 times 2, that's 8. Plus 1 is 9. A to the fourth power is negative 1 to the fourth power over 2 to the fourth power plus 1. Negative 1 raised to the fourth power, be sure you've got it parenthesis if you're checking in your calculator, gives you a 1. 2, 4, 8, 16 over 1 gives you a 17. So those are the first four terms of that series with that closed formula. Again, if we wanted to find a to the 53rd, we'd put a 53 in for n and a 53 in for n and work out the math. So you can jump to any n that you want to on these closed formulas. Let's look at number 2. It's asking you to find the 53rd term. So a sub n is 2n plus 5. If we want to find the 53rd term, we put in 53 in place of n. And then you can use your calculator, or 2 times, this is the same one that I just did over here, by the way, to show you. 2 times 53 is 106 plus 5 equals 111. So these are closed formulas. You just plug it in, no big deal. Let's look at number 3. Those are recursive formulas. Recursion is a little bit different, a little bit funkier. Let's look first at the formula. A sub n, in order to get a term, what you're going to have to do is multiply 3 times a to the n minus 1. N minus 1, like if we were looking for the 10th term, 10 minus 1 is 9. We'd have to know the 9th term to plug that in. So in order to get a sub 10, in order to get the 10th term, we'd have to know the 9th term. We can't just plug it in. We've got to know what that term was, and then what else do we do into it? Plus 2. Okay, so for this particular problem, they're just asking you for the first 4 terms. So a sub 1 is going to give us 3 times, oh, here's the problem with a sub 1. Let me cross that out. A sub 1, we don't have a way of knowing that. Let me rewrite that. A sub 1 is 3 times a to the 1 minus 1 when you plug in a 1 there. And we've got 3 times a to the 0. We don't know, not to the 0, sorry, that's not an exponent, that's a sub, meaning the term that is the 0 term. We don't have a 0 term, which is why, if you'll look, they hand you the a sub 1 term. Let me see what I have caused you to miss. Doesn't look like anything there. But you fitting to miss it, and you figured I'd screwed it up, didn't you? Okay, so a sub 1 they will hand to us, and you can see they're telling you, no worries, a sub 1 is a 5. Now we can go and progress, now that we've got our starter number. So that's the first term. Let's look at the second term. 3 times a to the sub 2 minus 1 plus 2. So a sub 2 is going to be 3 times what the first term was, a sub 1, and we were given that. So 3 times 5 plus 2, that's 15. So the second term is 17. The third term will build off of the previous one. A sub 3 is 3 times whatever a to the n minus 1, and in this case the n is a 3 plus 2. So we need a sub 2. So this will be 3 times a sub 2. A sub 2 was a 17. That's 34. So 34 plus 2 is 36. We're just working our way down the row there. 3 times, not 2 times. 3 times 17 is 51. 3 times 7 is 21, yeah, 51. So 51 plus 2, which is 53. We need the fourth term, that's 3 times a sub n minus 1. That's a 3, so we've got to go grab 3 times what a sub 3 was. A sub 3 is a 53. So 3 times 53 is 159. 159 plus 2 is 161. So there are the first 4 terms of this recursive one. We didn't even have to work on the first one. They give that to you. They have to give that to you in the problem, because there's no way you can figure out what a sub 0 is. There's no such thing as a sub 0. So when you have to go back, when you see that n minus 1, you know that's a recursive formula. Now see what happens. If we wanted to find the 53rd term in here, we'd be saying 3 times a to the 53 minus 1, And we'd be trying to find, we need 3 times the 52nd term. We don't have the 52nd term. So in recursion formulas, if all you've got is the recursive formula, you've got to go all the way through 3, 4, 5, 6, 7, 8, all the way to 51, 52, 53 to get the 53rd term. So recursive formulas, there's cursing in there for a reason. I won't ever ask you to do that. Nobody's going to ask you to do that. It's not a plug-in. It's very much a step-by-step. The best description of the difference between a closed formula and a recursive formula that I found, I just love this. If you are stuck with a recursive formula, that is like having to climb the stairs. In order to get to the 53rd floor, you've got to climb from the first floor to the second, to the third, to the fourth, to the fifth, all the way up to the 52nd, so you can use that number, and then to the 53rd. Whereas a closed formula, up here, these closed formulas, you can get to the 53rd floor simple, just plug it in. So this is an elevator situation. This is a staircase situation. I like that difference. We're not getting in the weeds that much with these, but I just thought that was kind of cool and wanted to share it with you. Okay, let's look at number 4 on Thomas's homework. We're moving on from there. You're done with we're done with recursive and closed formulas. Now we're looking at factorial notation. I love factorials because it looks like N exclamation point, like N, that kind of thing. I'm going to skip the description he gives you there and go straight to the actual number. 5 factorial is what it's called. You're not supposed to scream 5, but it means start with 5, multiply all the way down 5 times 4 times 3 times 2 times 1. That's 5 factorial. If you want it, you can multiply it out and you get 120. So number 4 asks you to figure out what 7 factorial is. It's 7 times 6 times 5 times 4 times 3 times 2 times 1. That's kind of a nifty little thing. Let's see, there is not a button on your calculator for that. We've already got 120, which takes us this far. So you could just take 120 and multiply it times 7 times 6. Order doesn't matter. So if you wanted to say that's 120 times 6 times 7, that'd be good. Or if you just prefer the straightforward approach, 7 times 6 times 5 times 4 times 3 times 2, and just for good luck times 1, not necessary because multiplying times 1 doesn't change it. And we get 50/40 out of that, and that's the answer. One little detail that you got to know this, that 0 factorial, which looks like it ought to be kind of like 0 times 1, is not. We agree that 0 factorial is a 1. So, yeah, that's good. So 0 factorial is a 1, and just remember it, memorize it. Okay, number 5 asks you to write the first 4 terms of the sequence here. So we're bringing back sequences so we can include a little bit of factorial nonsense in there. Factorial there and factorial there. Okay. So a sub 1, this is a closed formula because we've got no n minus 1s going on. We'll be able to just go straight up to the elevator if we wanted a to the 53rd, which we don't, or a sub 53, the 53rd term. Let's find the first term. 1 plus 1 factorial over n factorial. That's 2 factorial in there. So that's going to be 2 times 1 over 1. That's just going to give you 2 for the first term. A sub 2, the second term, will be 2. N is 2 here, so we put a 2 in for the n's and an n on the bottom. So 2 plus 1 is 3, so that'll be 3 factorial over 2 factorial. 3 factorial is 3 times 2 times 1. 2 factorial is 2 times 1. Now you can do all this math. 3 times 2 times 1 is 6 divided by 2. But you can also recognize that 2 times 1 is on top and 2 times 1 is on bottom. So let's divide those evenly out, and we end up with an answer of 3, which is what we'd get no matter how we did this problem. A sub 3 will be 3 plus 1 factorial over 3 factorial. So this gives us 4 factorial over 3 factorial. 4 times 3 times 2 times 1 over 3 on down. And again, you've got some cancellation and you end up with a 4. If you'd multiplied this out, 4 times 3 is 12, times 2 is 24, so 24 is on top, remember that. 3 times 2 times 1 is 6 on bottom. 24 divided by 6 will give you a 4. Cancelling's a whole lot easier. Let's get the fourth term. 4 plus 1 factorial over 4 factorial. Pretty sure you can see the progression and guess what this is going to be. This is 5 factorial over 4 factorial. 4 times 3 times 2 times 1 over 4 factorial. Cancel, cancel. You get a pretty little 5 right there. So the answer, got 4 answers there, 2, 3, 4, and 5 for those steps. Next thing, we're moving quickly through here. Next thing we're looking at is called summation notation. That means what if you wanted to add all this stuff up? How do you indicate mathematically that you're going to be adding all this stuff up? Let's look at how that's going to happen. Make sure I'm still on here. Let me give you a push up a little bit. There we go. Okay, number 6. This notation on number 6, you've got this little Greek symbol here that means you're adding. In math, that means we're going to add some stuff together. Our first term, k is what we're going to call our terms. It's called the index of summation. And we're going to start with a 1 there. That's why there's a 1 on the bottom of the first problem on number 6. The top number, 6, well, 1 is our lower limit. That's where we're going to start. 6 is our upper limit. That's where we're going to stop doing this. So we're going to add the first one, the second one, the third one, the fourth one, the fifth one, and the sixth one. And then what we're going to do each time is we're going to multiply 2 times that number squared. So our first term, let me see how I wrote this. I knew I wanted to write it in a specific way. Okay, so when k equals 1, what we're going to do is we're going to plug a 1 in here. So 2 times 1 squared is what that is. Do the exponent first. 1 squared is a 1. So 2 times 1 gives you 2. Then we're going to add that. That's what the summation is about. We're going to add that where k equals 2. So when k equals 2, we've got the formula is 2 times k is a 2 here, squared, a lot of 2's. Take care of this first, that's a 4. 2 times 4 is 8. Then we've got where k is 3. Let's take our formula. 2 times k squared. 3 squared is 9. 2 times 9 is 18. We've got 3 more to do here. Where k is 4, use the formula. 2 times k is a 4 here, squared. 4 squared is 16. 16 times 2 is 32. K is a 5. We're almost done to our upper limit. We've almost hit our upper limit. 2 times k is a 5 squared. 5 squared is 25. 2 times that is 50. And finally, when k is 6, we've reached our upper limit. That's the last one we're going to add. Use the formula. 2 times 6 squared. 36 times 2 is 72. So let's see, does he ask you to add that up? Expand and evaluate each sum. So we've expanded it. All this is the expansion. Adding it up, start either end you want. 2 plus 8, that's 10. I'm just going to handle that. Plus 18, plus 32, plus 50, plus 72 equals 182. So expand it out and evaluate each sum. Let's do the next one. Got a summation little guy going on here. I this time instead of k, no big deal. So I is the index of summation. We're going from 3 up to 5. So our I will be a 3, then a 4, then a 5. So the formula we're using is 2 to the I minus 3. So we need where I equals 3. We'll do where I equals 4. And we'll do where I equals 5, going from 3 to 5 for I. So the first time through, we've got 2 to the third, because our I is a 3 this time, minus 3. 2, 4, 8 minus 3 is a 5. We're going to we're going to sum that. We're going to add that. to 2 to the I this time is a 4, minus 3. Notice we didn't start with 1 and 2. It told you to start with a 3. K started with a 1, but this one starts with 3 and just goes up to 5. To the 4th, you can use your calculator. 2, 4, 8, 16. 16 minus 3 is 13. Next one you got going on is where I is 5, so we will add that. 2 to the 5th minus 3. 2, 4, 8, 16, 32. And 32 minus 3 is 29. 2, 4, 8, 16, 32. 32 minus 3 is 29. Yeah, my notes are bad. Oh, I see what I did. That's dumb. Okay, let's look at what we've got here. 5 plus 13 plus 29 equals 47. So expanding it out and evaluating it. Let's do our last one. It's super easy, but super weird. K is the index of summation. We're starting with a 1 and we're going up to 5. So let's look at where I equals a 1, where I equals 2, I equals 3, I equals, K, 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 and K equals 5. We're looking at all 5 of those terms, and the rule here is that the answer is going to be 4. So when K equals 1, the answer is 4. When K equals 2, the answer is 4. When K is 3, when we're plugging in a 3, we're not plugging in a 3 because there's nowhere to plug it in, the answer is 4, 4, and 4. That's the expanded version. To get the total, you just add those up, or 1, 2, 3, 4, 5 times 4 gives you a 20. 1, 2, 3, 4, 5. Yeah, okay. All right, let's go on to the next page. Number 7, A and B, he wants you to reverse that. He wants you to give him the summation notation. I'm going to tackle those over here. Number 7. Let's see. Draw your little funky symbol. We need a K equals. What are we starting with? You can see that you've got 1 to the 3rd. Let me put it over here. You've got 1 to the 3rd, 2 to the 3rd, 3 to the 3rd, 4 to the 3rd, all the way up for a while. So we're going to start with 1. Our K is a 1. Our upper limit is a 7, so put a 7 up there. And then what's the rule? What are you doing to your K? You're cubing your K each time, taking the 1 and raising it to the 3rd power, taking the 2 and raising it to the 3rd power. So we are taking our K and cubing each one. And that's all you need to do. So this is the answer. On my math lab, they give you little blue areas to fill in each part they want you to fill in. Okay, B is not necessary for you to understand completely. You can follow it. You won't have one like it on my math lab. So K, where are we starting? We're starting with a 1. Where are we going to? We're going up to N. That's what we're going to call it there. We're going up to N. We go as high as we want to. Our upper limit is as high as we want to because we have a rule that will cover all of them. That rule, since you've been handed it, you will use there for the rule. Don't worry about understanding that. It's above our level. Let's look at number 8 and look at this sequence. They want you to find A of 10, 100, 1,000, 10,000, and 100,000. We're just tacking on zeros each time. So let me scoot us down here and we will finish up this sheet of paper. So number 8, the formula is A sub n equals 1 plus 1 over n raised to the nth power. So when we're finding the 10th term here, plug in tens. 1 plus 1/10 raised to the 10th power. Grab your calculator. So A sub 10, remember this is just a symbol. It's telling you we're using the formula we've called A, and we're on the 10th term of this. So let's add 1 plus 1/10, and I know you can call it 1/10, 1.1 if you want to, it doesn't matter. But there you can see 1 and 1/10, and then we're going to raise that to the 10th power. And we're getting I'll take it about 4 places, 5937, good enough. Let's do a to the 100, or not to the 100. I keep saying that, and that's not right. It's a sub 100. It's our 100th term. So 1 plus 1 over 100 raised to the 100th power. 1 plus 1 ABC 100 equals, we're going to raise that to the 100th power, and we're getting 2.7048. 4 digits out. Let's look at a to the 1,000. One plus 1 ABC 1,000 equals, and then raise that up to the 1,000th power. We're getting a tiny bit more, 2.7169. And then there is a 2. So 2.7, I blew that, 2.717169. There we go. And then a 2 is after that, the 5th place, so we're good. Okay, let's look at a to the 10,000th.